Hello everyone, welcome to this video. In this video, we are going to solve a LeetCode problem using two different methods and you will learn the basics of lists. So let's get started. Okay, so the LeetCode question is best time to buy and sell stock. You are given an array prices where prices I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. And we have to return the maximum profit that we can achieve from this transaction. And if you cannot achieve any profit, we have to return 0. So basically, you won't do any kind of transaction. So let's first look at the example. On the first day, the stock price is 7, then 1, 5, 3, 6, 4. So by the way, this does not happen in real life because if you knew the stock prices in the future, you could have easily chosen your best profit. But for the sake of this question, let's assume that. Okay, so the first day has value 7, then 1, 5, 3, 6, 4. If we think intuitively, let's say we buy the stock on the first day, which is value 7, we ideally want to sell it at a very high price, which is more than 7 in the future itself. So what our logic would be, we will look forward in the array into the future and we will find out what is the maximum price that we can sell, right? And in this example, like if we buy at 7, unfortunately, there are no prices which are more than 7. So you won't be able to make a profit. Right? Now, let's look at 1. If we buy at 1, you will find out that 6 is something which is the maximum. And it is also greater than 1. Right? So you make a profit of 5. You can basically buy at 1 and then sell at a future date at price 6. So you make a profit of 5. And let's say you buy at 5, you again can make a profit of 1 by selling on this day at a price of 6. And similarly for this particular day at 3, you can get a profit of 3. But if you buy at 6, unfortunately, there are no prices which are more than 6 in the future, so you won't be able to make a profit. So ultimately, what we want to calculate is that you make a maximum profit of 5. And this will only happen if you buy at rupees 1 and you sell at rupees 6. It's given in the example as well. You can buy on day 2 and then sell on day 5, which is at price 6. And similarly, you can look at this example too, which basically says the stock prices are 7, 6, 4, 3, and 1. So you see that the stock prices keep decreasing. So any day you buy, you won't find a price which is greater than that particular day. So you won't be able to make a profit here. Right. So now that we understand the problem, let's think how can we go ahead and solve it. What you can do is, like if you're standing on ith array, you can again write a j loop, or you can again write a loop. Let's say these are the values. So let's say you are standing at index I, you can first iterate over I, and then you can also write a j loop inside this, which will calculate the maximum from I plus 1 to n, right? So this will calculate what is the maximum in this suffix of the array, which is between I plus 1 to n. If you go by this logic, you will see that your time complexity will be order of n squared. Why is this? Because there are two loops. One is I, one is j. Both of these loops are running for total n steps, and because they're nested, it will be n squared in total. And what is the time complexity? We are not storing anything, so the space complexity will be order of 1, which is like good enough. But we want to do better. We want to do better than n squared. Pause for a bit, think how you can optimize this, and then see the final solution. So to tackle our problem, what we can do, we can iterate from the back. We will keep maintaining a running maximum, and this will help us to get the suffix maximum very quickly. Let's try to solve this one using a proper dry run. This will be our running max. This is our ith index, and this is our max profit. First of all, we are standing at, so because all of these are indexed 0, so let's start with index number 5. Index number 5, we see that the running maximum is 0, and we are currently standing at index 5. So the max profit still remains 0, right? Now we go to index number 4, and before moving to index number 4, we will update the running max to 4. Now we move to index number 4, we see that, okay, what is the running max? It is 4. So what will be our profit for this particular step? It will be 4 minus 6, which is minus 2. But we will take the maximum profit. So it will be max of 0, minus 2, which will still be 0. So still we haven't seen any profit. And then we go ahead and update the max to 6 because we've already seen this. Now we move to index number 3. So we see that now the running max is 6 and our maximum profit is 6 minus 3, which is 3. Now we will take the max of 0, 3, which is equal to 3. And we update our maximum profit to 3. Right? And then we see that, okay, the running max is still 6. It's not changed to 3 yet because 6 is greater than 3. Then we move to index 2. We see that the running max is still 6 and we are at I position 2. Now we will calculate the maximum profit again. So the maximum profit here is 6 minus 5, which is 1. So still the maximum profit remains 3 because max of 3, 1 is 3 again, right? Now we move to I equals to 1 and we see that still the running max is 6, but now we'll see the maximum profit is updated to 5, and similarly we will move to index 0 and we will see that the running max was still 6 and maximum profit is 5. So you see that here we have iterated over each element only once, and that is what we want here. We have reduced the time complexity from order of n square to order of n just by using a simple trick, which is iterating from the back. Okay, now let's implement the solution. First, we can take out the length of the prices. Then we can also maintain our answer, which is currently 0. And we will also maintain our current max, which is also 0 right now. And then we can iterate from the back, which is I in range n, minus 1, minus 1. Okay. So now we need to calculate the answer. So answer will be, okay, let's also try to maintain what is the current profit we have. So the current profit is currently current max minus the current price. And then we will take the max of, so my answer will be max of answer, current profit. And then we go ahead and update our current max. So this will be updated to current max, comma, the price is current price. Then we can finally return our answer. Let's try to submit this. Okay, so we see like one particular problem here. We started iterating from n, right? But it has to be n minus 1 because all of these arrays are index 0. So that was a mistake that we did. So now let's try to submit this. It should hopefully work. And yes, so after solving this, you can calculate like what is the time complexity. And we have only written one for loop. So the time complexity of our solution is order of n. And we are not using any extra space. So our space complexity is also order of 1. Now, one more thing you can think, you could have also thought about this problem in a reverse way. So let's say you are given this particular array. Instead of thinking that you are going to buy at this particular day and sell at a maximum profit in a future day, what you could have also thought of is, let's say you are going to sell at this particular day, then you need to find out what is the minimum stock price in my previous days, right? So in this scenario, you will have to maintain a prefix minimum instead of a suffix maximum, and you can iterate from the start of the array itself. I would urge you guys to code up this solution. Okay, thanks for watching this video. See you in the next one. Keep coding.